We are now looking at Physical Sciences Paper 1, November 2022, question 10, which is photoelectric effect. Without any waste of time, let's get straight to it. Question 10, what are we given here? It says a light, in fact, light is incident or shone on the cathode of a photoelectric cell. So light is shown on the cathode of a photoelectric cell connected to a battery and a sensitive ammeter as shown in the diagram here. Okay, so let us look at our diagram. There is the light that is shown into the cathode there. We have our negative here and we have our positive this side. This is our ammeter. So when this light is shown here, if it has enough work function and enough energy, it means that electrons are going to be ejected. But let us look at our questions here. 10.1. What do we have here? What conclusive evidence about the nature of light is provided by the photoelectric effect? Okay, we know that light has a particle nature. Light has a particle nature. That is the conclusive evidence that one can take out from this, is that light has a particle nature. So light has a particle nature. Light has a particle nature. All right. Or light is quantized. You can say light is quantized, but I think stick to light has a particle nature. Let's go to the next question here. The cathode has a work function, so we are given the work function. So the W naught, the work function is given to us as 3,42 times 10 to the power 19 joules. Okay, so we are given the work function there. We are given the work function as 3 times 10 to the power 19. Okay, now what are we looking for here? It says define the term work function. So we are going to use this somewhere. It's fine. Define the term work function. Work function, now you get 2 marks in the exam to say the minimum energy that can eject electrons from a metal surface. So we have there the minimum energy, that can eject, or required that can eject. You can also use remove here, you won't be penalized. Eject electrons from a metal surface, from a metal surface. Okay, so what we have there, the minimum energy required, or the minimum energy that can eject electrons from a metal surface. Now in 10.3 we are given a light of frequency. Which is 5,96 times 10 to the power 14 hertz, which is shown into the cathode. Now what are we asked to do here? We must calculate the maximum kinetic energy of an electron ejected from the cathode here. All right, so we go to our formula sheet now and see, because we are given the frequency and then we are also given remember I said something this side, there's something I've written for you here. We are given the work function as well. So we do have our data there. Let us now go to our formula. We know that E equal to W naught, which is work function, plus EK. This EK is max. Okay, therefore E we can expand it to HF, which will be equal to, this can also be expanded to the threshold frequency, plus we are looking for the EK max. So there's no need for me to do to change the EK max or expand it. Now this H is always constant. It's called the Planck's constant. So I have 6,6 times 10 to the power negative 34, which will be equal to, I have the threshold frequency, which is given here as what? As 5,6. 5,6. In fact, 5,96. This is 5,96. 5,96. Right? 5,96 times 10 to the power 14. What else do I have here? And therefore, I also have times 10 to the power 14. I think I made a mistake somewhere here. Let's just look at this, because this is the frequency, right? So I can't have the equal sign here. In fact, these two are supposed to multiply each other. So we made a mistake there. Let's rectify it. The frequency that I have, not the threshold frequency. The frequency that I have, it was 5,6. Okay, 5,96. In fact, we have 5,96 times 10 to the power 14. All right, then equal to our HF now. Let us look at HF. Now the work function is given as it is. Remember, we had what there? We had 3,42 times 10 to the power 19 that we had, and then plus what? Plus EK what? EK max. Okay, so if we have this, what are we going to do then? All right, so from here what we do is we just go to our calculator. We just go to our calculator here and see what we have. So we have to punch what we have on the left hand side. What do we have then? We have 6,63 and then exponent minus 34. We close the bracket. In fact, we can open it here. We are multiplying 5,96 exponent to the power 14 here. Okay, I see it. And then what do we get from this side? We can't get a negative number there. Something is not coming right with our calculator. So let's start over again. Minus 34. Okay, we open the bracket. It's 5,96 exponent to the power 14. All right, what do we get there? We get 3,95148 times 10 to the power what? Times 10 to the power negative 19. So can't we just minus this with what? With 3,42. So minus 3,42 exponent negative 19 as well, so that we can get our kinetic energy. Oh, there we go. Here's our answer. 3, in fact, it's 5,3 times 10 to the power negative 20. So we have 5,3. So our EK max equal to 5,3. You can say 5,32 times 10 to the power negative what? 20 joules. That's how we get our what? Our EK max. We then now move to 10.4. 10.4, we are given here that the ammeter registers a constant current of 0,012 amperes. Calculate the minimum number of photons of light that strike the cathode in 10 seconds. So we are given the current and we are given the what? We are given the time. So we are given the current and the time. So we can look for what now? We can look for the charge. What do we have? We know that charge equal to current and change in time. Are we given current? Yes, 0,012, and then we have our time. It's in 10 seconds. No need to change it. We just go to our calculator here. We just punch what we have. Just punch what we have here. What do we have? We have, what do we have here? We have 0 comma, so we have 0 comma, just move the calculator here so we can see. We have 0 comma 0 1 2, 0 comma 0 1 2, and then we have 10, and then we do this, and then what do we do now? We say equals to, what do we get here? We have 0 comma 1 2, so we have 0 comma 1 2 charge. But what are we looking for? We are looking for the what? The number of what? Of the number of photons, which are electrons in this case. The number of photons. The number of photons. So we can say n equal to, we now have the charge over what? Over the electron. So now we have n equal to, do we know our charge? Yes, our charge is 0 comma 1 2 over, what do we have again here? Charge of an electron here will be what? Will be 1,6, which will be times 10 to the power negative 19. Okay, so the charge of photon here, we have number equal to here, if we punch the 2, is 0 comma 1 2. Let's look at this, 0 comma 1 2. We can just divide by 1,6 exponent, in fact that's not exponent, 1,6 exponent what? 1,6 exponent negative 19. 1,6 exponent negative 19. Okay, and then our answer there is 7,5 times 10 to the power 17. So we have 7,5 times 10 to the power 17. That is our answer there. Okay, I hope you get it now. You first look for the charge because you never had the charge, but we were given current and the time, and therefore now we can look for the number of what? Of photons, which is electrons in our case. Okay, so we can move now. We can move now to 10.5. 10.5. In 10.5, what are they asking us in 10.5? The intensity of the incident light is now increased. So we are increasing the intensity of what? Of incident light. How will this change the reading on the what? On the ammeter? Choose from increase, decrease, or remain the same and explain your answer. So what do we need to know here is that when we increase, in fact, we can first try and explain, and then our answer will be there. We can leave a space for our answer here, but what we need to know is that more photons will strike the surface of the metal per unit time because it is increased. So more photons will do what? Will strike the surface of the metal per unit time. That is the first reasoning there, per unit time. And then what else can we say here? So this will mean that more electrons, so hence more electrons will be what? Will be ejected, or more electrons are ejected. More electrons are ejected. More electrons are ejected per unit time. So we have that here, per unit time. Hence we can come and say it is what? It has increased. So we say increases here. Increases, why? Because more photon, in fact more photons strike the surface of the metal per unit time, which means what? More electrons ejected per unit time. What about current then? We must say that it will result in what? In increased current. So this will result in increased current. Increased current. Because when we look at our question here, we were asked about what? About the current. So we must conclude our answer by saying whether the current is going to increase or not. So we said increases is fine. More photons strike the surface of the metal per unit time. More electrons injected per unit time. That's how you answer 10.5. Grade 12, that's how we answer question 10, which was photoelectric effect.